To continue our work with finding the values for all 6 trigonometric functions, the next angle that we're looking at, or rather the next real number input that we're looking at, is 5 pi over 4. It might be helpful as we practice these to continue referring back to your unit circle to help identify what your major point is that you're going to be using. In this case, I'm going to kind of go through this imagining that I don't have the unit circle for a moment. And we'll talk about this more in a later lecture because this becomes kind of a standard technique. But here's how I'm going to think about it. 5 pi over 4. Well, I know that this is greater than pi, but it's not quite as large as 3 pi over 2, meaning I have to be in quadrant 3. Why do I care about that? Well, I know that in quadrant 3, both cosine and sine are going to be negative because both x and y are negative. So I'm going to go ahead and jot that down. X is negative, y is negative. But I also remember that when we introduced these different reference angles back in our unit circle, we had 2 different variations. In one of them, we split the unit circle into 8 equal arcs, which were each multiples of pi over 4. And one of the things that we noticed is that each one of the ones that was pi over 4 after simplifying, where it had some 4 in the denominator, they always had the exact same x and y ignoring signs. It was always square root of 2 over 2. So with that information, I can go ahead and say, oh, then that must mean that the point that I'm referencing here on the unit circle is negative square root of 2, negative square root of 2 over 2. Excuse me, both of them are negative square root of 2 over 2. So again, the idea here is playing off of the idea. We know what pi over 4 looks like, and we know that the other angles that are at that 45-degree measurement in the other quadrants have the exact same values, ignoring sine. We identified, based upon this number being between pi and 3 pi over 2, that we had to be in quadrant 3, which meant both x and y had to be negative, so this is how we came up with this point. And now we have enough information to go ahead and fill out our different values. So sine of 5 pi over 4, we're just going to grab our y-coordinate, negative square root of 2 over 2. Cosine of 5 pi over 4. Same idea, this time just grabbing the x-coordinate, negative square root of 2 over 2. For our cosecant, we're going to look at the reciprocal of our sine function. So this would be 2 over negative square root of 2. Don't like this square root in the denominator, so I'm going to go ahead and rationalize the denominator by multiplying the top and bottom by the square root of 2. I'm also going to pull this negative out of the denominator and push it off to the side. So this becomes negative 2 times the square root of 2 over 2. Oh hey, I have a common factor of 2 that can be cut out of both parts, meaning my actual final result is just negative square root of 2. For the secant of 5 pi over 4, this is the reciprocal of my cosine function, and my cosine and sine are actually the same here. So I already know that it'll match my cosecant. It'll be negative square root of 2 as well. What about tangent and cotangent? Well, in each case, we notice something here. This is something we actually talked about in that previous lecture. On these 45 degrees, whether we're in quadrant 1, 2, 3, or 4, we notice that ignoring sine, x and y were essentially the same value. In fact, in quadrant 3, x and y are exactly equal to each other. So no matter how you want to write this quotient, negative square root of 2 over 2 divided by negative square root of 2 over 2, you're going to get 1 either way. Even if you flip it for cotangent and write it as cosine divided by sine, you're still going to end up with 1 as your final answer. So this is going to be the set of 6 trigonometric function values for our second of the 4 angles. The next angle that we're going to work on, I keep saying angle, but again, this is also just any real number that we're using for t here. I'm just making the connection that these apply as basically an angle measure for our central angle, was t equals pi. Now this one's kind of interesting. This was one of our 4 major points. So this one is when we're just to the left of the center, basically when our xy values are negative 1 and 0. This one doesn't really lie in any of the quadrants because it instead lies on the x-axis. But we still have the values for x and y from our point, and that's enough to work with. Sine of pi is going to be equal to 0, our y-coordinate, and cosine of pi will be equal to negative 1, our x-coordinate. Now this is interesting. If I try to take the cosecant here, that's going to create a problem for me, because I'm going to end up with trying to take the reciprocal of 0, which is undefined. So actually at pi, because sine is 0, we say that cosecant is undefined. We cannot divide by 0, so we just have to leave it like that. Our secant, however, doesn't have the same problem. In fact, interestingly enough, if we were to take the reciprocal of -1, we actually just get -1 again. You could think about it like this. This is -1 over 1, whose reciprocal is 1 over -1. It's the same number either way. What about for tangent and cotangent? Well, remember that tangent is defined as y over x. So in this case, our tangent at pi, our y-coordinate is 0, and our x-coordinate is -1. 0 divided by any non-zero number equals 0. So that's our tangent value at this point. What about our cotangent? Well, think about this. If we're taking the reciprocal of 0 over -1, we're running into something that is undefined again. This is something that we can kind of draw bigger strokes around. The central idea is that anytime our y-coordinate is 0, cosecant and cotangent will be undefined. What would happen if, say, x were to be equal to 0? Well, then it would be secant and tangent that would be undefined in those cases. So you can kind of start to see how these different ideas relate and bounce off one another. But the key idea, at least to start with, is take your real value for t, find the point associated with it, use those x and y coordinates to fill in all 6 trigonometric functions. The last one that we're going to do for practice here is going to be when t equals -pi/3. Now this one is a little bit different because, well, we're dealing with a negative angle. So in this particular case, we remember that this means we're actually going to wind clockwise instead of counterclockwise from our starting position. So we know that this, going down -pi/3, is going to leave us in quadrant 4. This is going to be the case where x is positive and y is negative. But in and of itself, this isn't super helpful because we haven't really talked about how to find the angle for this specific value. But we can do a little bit of a cheat here. We can instead deal with its coterminal angle, another angle whose terminal side is in the same position. One of the ways we can do that is by adding 2 pi. Basically, go a full revolution around and you'll end up back where you started. So if we add 2 pi to this, we'll come up with a coterminal angle that will have the same xy value for the point on the unit circle. I'm going to think about 2 pi as 6 pi over 3, so adding it here, this will make it 5 pi over 3. This is one of those that we should have memorized as part of our work on the unit circle. The xy point associated with 5 pi over 3 is going to be 1/2 and -√3 over 2. Now we have our x and y, so the rest is just using our formulas. The sine of -pi over 3, grab the y coordinate, so that'll be -√3 over 2. The cosine at -pi over 3, that's our x coordinate, and that'll be 1/2. Our cosecant, well, that'll be the reciprocal of our sine. Now we've seen this before. Oops, it should not be pi over 2, it should be pi over 3. When we took the reciprocal of √3 over 2, we ended up with 2 √3 over 3. So all we need to do is make sure that we include that negative sign there. Over here, the reciprocal is a little bit easier for our secant. Secant of -pi over 3 is going to be +2. And finally, the ratios. Tangent of -pi over 3 is going to be our sine value divided by our cosine value, so it'll be -√3 over 1, or just -√3. And now for our cotangent, we'll simply take the reciprocal. And again, this should kind of be recalled with some of the work that we saw previously. When we got -√3 as the reciprocal of something else, it was because earlier it had been 1 over -√3. All we have to do is rationalize that denominator, so our final answer is -√3 over 3. So these are many different examples of how we want to find the various 6 trigonometric functions for a given value t. The key idea is always the same. Start by identifying the point that's associated with t that's on the unit circle, because those xy values are essential to finding the 6. Once you have those xy's, then you just need to follow the same pattern each time. Sine is y, cosine is x, cosecant is 1 over y, secant is 1 over x, tangent is y over x, and cotangent is x over y.